live.
Hello everybody, I'm Ms Joyce, the O and A level chemistry tutor from A Scorers Enrichment Center. Now I understand that during this circuit breaker period, everybody has to be kept at home, and therefore I have actually received quite a number of questions from my students through the WhatsApp and an email. I suppose they are really bearing themselves in books and also doing tutorials since they have nowhere to go, which I think is a good thing. It's a good time for them to catch up on whatever they have missed out in the first quarter of the year. So I've told my students that yes, we're going to take it positively and make sure they make full use of this 1 month to brush out whatever you are lagging behind. Alright, so anyway, I actually received these questions from one of my students from SAJC last evening, and this is actually a deductive questions from the H2 chemistry syllabus, and it's one of her tutorial questions. So let me read out the questions to you, and it says that in fact, this question is one of the A-level questions from the year 202. Alright, and it says that it's about this compound FCH8O2, which is formed when the phenyl ethanoate CH3CO2 C6H5 is warmed with the aluminium chloride, and the compound F is insoluble in water but dissolves in sodium hydroxide solution. Now it also reacts with 2,4-dinitrophenylhydrazine but not with the Phenylen's solution. And at the same time, it also reacts with the bromine water to give G, that is C8H6O2Br2, and with the alkaline aqueous iodine followed by the acidification, F gives H, which is C7H6O3. Now next, compound H dissolves in both the sodium hydroxide and the sodium carbonate solution. Now this compound H can also be obtained by reacting oil of the wintergreen J with hot NaOH aqueous solution, followed by the sulfuric solution, the sulfuric acid solution. Alright, so you can see that the question has also given this structural formula of J. Now after reading the questions, in fact, it's easier to start off the working or the solution by using this structure J. So first of all, since it says that, oh, by the way, the question is missing, and in fact, the question wants us to find the structural formula for G, for F, G, and H. All right, for F, G, and H. All right, so let's work it out by starting off with this compound J. So if you were to look at compound J, it has mentioned that J can also be, in fact, H, all right, can be obtained by reacting J with hot NaOH followed by the sulfuric acid. Now this is actually referring to the reaction of the saponification. Now it goes like this. Okay, let me draw the structure of J first. Alright, and you can see that you got to react with the sodium hydroxide. Okay, and this gives us the structure. I'm gonna bear with it for a while for the for my handwriting, because just started using this platform, and yeah, technology no doubt is really useful, and it helps us to be able to share so many things online with everybody, but we still need to go through the learning period, so bear with me for a while. I'm trying to get this written up nicely. Okay, so you can see that you have this structure. Now upon reacting with the sodium hydroxide, this compound J will undergo the process of the saponification, all right, to form a
Let's press the pen.
all right, to form the sodium salt. All right, the sodium salt. In fact, if you look at the compound J, it has this ester functional group and a phenol functional group. All right, so after the saponification process, it will form the sodium salt all right, and a byproduct of the ethanol, all right, CH3, sorry, the methanol, CH3OH, right, CH3OH. So next, because it also mentioned that after the process, it has the salt, the sodium salt is actually reacted with the sulfuric acid. So therefore, this compound of the sodium salt will react with the hydrogen ions from the sulfuric acid to give this substance, and that is the compound H. Right, could you see that? Okay, so that is the structure H. And if you were to look at the chemical formula of the structure H, it says C7H6O3. That tallies to the structural formula of H. All right. And in fact, the H has the carboxylic acid functional group and also the phenol group. Okay, I'm not sure whether I can scroll this out.
Press this.
Okay. Yeah, for those of you who are learning with me, you may need to jot down the structure. I don't think I have a very big screen to draw all the structure in this screen here. Okay, so that is your H. Okay, and then back to the question, it has mentioned that this compound H dissolves in both the sodium hydroxide and the sodium carbonate, which is correct because the sodium hydroxide, that is an alkali, can react with the phenol group and also the carboxylic acid functional group. Okay, the phenol and the carboxylic acid functional group. And because of this carboxylic acid functional group, it can also react with the sodium carbonate, as we know that carbonate reacts with the acid to form salt, carbon dioxide, and water. All right. Okay, so let's move back now. How do we get H? So from the question, it says that when F reacts with the alkali aqueous iodine followed by the acidification, it gives H. So what is this reaction all about? It's actually referring to the iodoform test, right? The iodoform test. So it shows that the F, all right, the structure F must have a carbonyl functional group. All right, so how do we deduce the carbonyl functional group? So in fact, this F has this structure. So this is the compound F. How do I know that? So let me write out the whole equation first. Right? And if you look at the structure of this this molecule here, this compound here, it is similar to this structure. All right? And how do we get this? It's because of the acidification of this compound, this structure here. Okay, let me draw it out again. Alright, so this is the compound H. Alright, this was compound H that we have looked at it earlier on.
Yeah, I can just see.
Alright, so this was the compound H that we have looked at it earlier on. So since it says that the F give H after it has undergone the Ardo form test, so this structure of, you got to work backwards, in fact. You have to work backwards to derive what will be the reactant upon reacting with the acid, the acidification process will give H. So now you work backwards, you can see that this is actually the sodium salt. Alright, the sodium salt that we have derived. And how do we work backwards from this sodium salt to derive the structure of F? So according to the Ardo form test, if I have this structure of the salt, it means that this part of the molecule, alright, has this methyl group that's attached to it. Alright, such that this ketone, this ketone functional group, after reacting with the iodine, the aqueous iodine with the alkaline solution, it will give this sodium salt. Alright, and 3 moles of the hydrogen iodide. Alright, so with this, we can derive the structure of F. So what are the other informations of F that will allow us to further confirm that this is the correct structure? Is from the question that's given here. It says that with bromine water, in fact it is from the second statement that says that F will react with the 2,4-dinitrophenylhydrazine, that's 2,4-DNPH, but not with Phthalate solution. Now the test of this 2,4-DNPH is to test for the carbonyl compound. But what about the Phthalate solution? Now Phthalate solution will not give a positive result if the compound is a benzaldehyde or a ketone. Alright, so since it says that it does not react with the Phthalate solution, then it means that this F must be a ketone. It cannot be an aldehyde. So you can see that this is definitely a ketone. Alright, because we know that an aldehyde will have a H that's attached to the carbon of the carbonyl functional group. Okay, so this is the structure F. Okay, now I'm going to erase this solutions, right, to move on further to find the structure for G. Okay, let me get this out. We shall keep the let me get this out also. So I suppose those who are watching the live stream and you're learning together with me, you have gotten all the structure. Okay, so nonetheless, it says that F gives G, alright, when it has reacted with the bromine water. Now, since we know that the structure of F, okay, let me redraw the structure of F again. Okay, this is F. Alright, that's a structure of F. And In this structural formula of F, you can see that this is a phenol group, or a phenol functional group. And we know that a phenol functional group will direct the bromine, all right, to the 2, 4, 6 position. So therefore, upon reacting with bromine, Br2, that's the aqueous bromine, we will get this structure. Whereby the bromine is attached to the 2nd, 4th, and the 6th position. But if you look at this structure, the 2nd position of the benzene ring has been taken up by the ketone, all right, the ketone functional group. So therefore, we have to put the bromine on the 4th and the 6th position. So you're going to count it like that. This is 1, 2, 3, 4, 5, 6. All right, since phenol is the main functional group, so now we're going to put a Br here, which is the 4th position, and then the 6th position, another bromine. All right, and that gives us the structure G. Oops, G. All right, and what is G? G is C8H6O2Br2. And you can see that it tallies to the chemical formula. All right, to make sure that you got the correct structure, you have to check the number of the elements, all right, number of elements like for the whole molecule that tallies to the chemical formula. All right, okay, so students, do remember that when you have a bromine reacting with a phenol base compound, this phenol will direct the bromine to the 2nd, 4th, and the 6th position on the benzene ring. All right, so that's how we get this structure of G. Okay, so probably I can also draw the structures of H for those of you who didn't get it earlier on, so that you can get a more comprehensive understanding for these questions. Okay, and that is the C. All right, so that's the structure of H. Okay, so I hope that by sharing the solution for these questions, especially those students who are working on their tutorial and you have encountered these questions but you have problem with this, I hope that my solution will give you my solution will help you in doing your homework. All right, so feel free to check with me if there's any questions. Okay, and I hope to see you again on live soon. All right, okay, thank you everybody. Bye, good night.